Today we're looking at section 610, which is the integration of rational functions. This time we're using partial fraction decomposition, if you remember from pre-calculus. But before we jump into that, where does partial fraction decomposition come from? If I had something like 2 over x plus 2 plus 6 over x minus 1, what would we do to add those two things together? You'd come up with a common denominator, which are these two terms being multiplied. So we'd have 2 times x minus 1 plus 6 times x plus 2 all over this quantity. So once they're over the common denominator, you would simplify. You have 2x minus 2 plus 6x plus 12. The bottom you could FOIL it if you wanted to, x squared plus 1x minus 2. And then if we combine like terms on the top, we've got 8x plus 10 over x squared plus 1x minus 2. Now, the question is, how do we go from this combined form back to the original? And that's where partial fraction decomposition comes in. So let's see if we remember how to do this. You'll want to factor the denominator. So we say that 5x plus 5 over x minus 1, x minus 4, plus 4 minus 1. The denominator factors into x minus 1 times x plus 4. And if you remember, we put the a over x minus 1 and a b over x plus 4. Does it matter which one comes first? Absolutely not. You are just trying to figure out what those two numerators are. And then we go through and multiply everything by the common denominator to clear the fractions. So we have 5x plus 5 on the left is equal to a times x plus 4 plus b times x minus 1. And then we assumed values for x. So for the first try, I'm going to say that x is equal to 1. So on the left-hand side, I have 5 times 1 plus 5, which is 10, equals a times 5 plus b times 0. And when we do that, we'll do a little mental math here. A is equal to 2. And we'll do this again, but this time we choose x equals -4. You want that one term to drop to 0. So if I put in -4 in for x, 5 times -4 is -20 plus 5. So here's a -15. This one is a times 0 plus b times a -5. And in this situation, b is equal to 3. So what happens is we can rewrite this now as 2 over x minus 1 plus 3 over x plus 4. So in pre-calculus, you're thinking, okay, great, I can do that, but why? What's the point? Well, when we step into our class, if we're looking to find the integral of this original problem, it's pretty tough. Substitution is not going to work there. It's not complete the square. It's not long division because the power in the denominator is greater. But if I use partial fraction decomposition, I've got two much more simple expressions, and I can use natural log of x on each one or natural log of u. So let's give this a go here. Integrate a proper rational function whose denominator contains only distinct linear factors. So linear means it's x to the first power. Distinct means you don't have anything that repeats. If you recall, when you have repeating factors, some special things happen. So let's start with the original problem. I'm going to set up the partial fraction decomposition. Let's see, this factors into -2 minus 3. This is equal to a over x minus 2 plus b over x minus 3. And again, you want to multiply through by the common denominator to clear all the fractions. And then next, you select the values of x that you're going to use. I'm going to start with x equals 3. 3 equals a times 0 plus b times 1. This one's pretty nice. B is equal to 3. Then I'm going to choose x equals 2. So 2 is equal to a times -1 plus b times 0. So a is equal to a -2. Now, we're going to rewrite the integral. This becomes its alternate form. It's the same thing as -2 over x minus 2 plus 3 over x minus 3 dx. Now, awesome. We just have to find the antiderivatives. Both of these are going to be u substitution. Where in the first piece, u is equal to x minus 2, du would be 1 dx. The second piece, u is x minus 3, du is 1 dx. You probably feel like you've done enough of these where maybe you don't have to write that out each time, and that's okay. But because the derivative of each term is 1, I don't have to do anything crazy. So this becomes 2 natural log of x minus 2 plus 3 natural log of x minus 3. And then what goes on the end? We need a plus c. That works out fairly nicely. All right, example 2, we're going to do the same thing. We're going to factor and get this whole thing set up. So partial fraction decomposition. So we have x. Now my a term is not 1, so that's always a little bit annoying. This takes guess and check. I'm going to go with a 2x and a 3x. Just guessing here at this point. And my factors of 2 have to be 1 and 2. So if I put a 2 here and I put a 1 here, I know I'm going to have a 3x and a 4x. Let's see if we can make the signs work. This would be a negative. Nope, this would be the negative and this would be the plus. So I'm just going to double check real quick. 6x squared minus 4x plus 3x minus 2. We're good to go. So we say that this is equal to a over 2x plus 1 plus b over 3x minus 2. These are still linear factors. We only have x to the first power, so we're good to go. Multiply through and clear the fractions. And then you want to assume values for x. It's a little easier to just see on the last one. So if you get a little bit stuck, what you can do is set it equal to 0. So you can tell me that 0 is equal to 3x minus 2. So x is equal to 2/3. That's the value that we're going to use here. This is x equals 2/3. So 2/3 is equal to a. Now I know when I put 2/3 in for the first x, this will be 0. Plus b, another fraction, but that's okay. 2/3 plus 1. So 2/3. The first piece is 0. 4/3 plus 1 is 7/3. Had to think about that for a second. Or 8/3. 2/3. Goodness gracious, it's too early for math. Okay, yeah, 7/3. And then to solve for b, we would multiply by the reciprocal. So b is equal to 2/3. Is my reciprocal 3/7. And cross things out too soon. But b is going to be equal to 2/7. Great. That takes care of the first one, but what about the second one? So I've written too large here, but we'll make this work. This time I can say that 0 is equal to 2x plus 1. -1 is equal to 2x, so x is equal to a -1/2. So that's the value that I'm going to use. So -1/2 is equal to a times 3 times -1/2 minus 2 plus b. This time this whole side is equal to 0. So -1/2. This is a -3 over 2 minus 2. This is -4 over 2. This is a -7 over 2. And when I multiply both sides by the reciprocal, -2 over 7, I know that a is equal to 1/7. Okay. So what do we do with the a and the b? Well, you rewrite the integral. So this is the same thing as 1/7 over 2x plus 1 plus 2/7 over 3x minus 2 dx. You could bring the 1/7 and the 2/7 to the front. You can call this like two separate integrals. They will require u substitution because the derivative is not just 1. So du is equal to 2 dx. Dx is equal to du over 2. So this whole problem becomes 1/7 in the front will be 1/2. We have a du on the top over u. The second piece, you're going to have a different u. So this time u is 3x minus 2. The derivative of that is 3 dx. So du over 3 is equal to dx. And when we rewrite the second one, the second problem, we have 2/7 in the front. I know there's going to be an additional 1/3 integral of du over u. So 1/14 natural log of u plus 2 over 21 natural log of different u plus c. And I ran out of my paper. We'll put it down here, plus c. And the very last step is you want to make sure you get those appropriate u values in there. So do that next. All right, there it is. So the longest part on these problems is the pre-calculus and the decomposition. They're good to know how to do that. So on the AP exam, you're only responsible for linear factors in the bottom. But if you remember back to partial fraction decomposition, there were other types. So I just left us a note. The following examples are not eligible for the AP exam, but they're nice to have. So if we have a repeated factor